And welcome back to another LeetCode problem. Today we're looking at a very easy problem, but easy problems are a good practice to do anyways, because they allow us to focus on the interview process or systematically approaching the problem, which is something that when you work on a more difficult problem is often something that gets interrupted by trying to figure out what the solution is. So for interview practice, what I do is I try to simulate the interview and going through the problem in a very systematic way. The first step is to read the problem description. Second would be to look at the examples and to ask constraints, look at the examples, and then come up with a solution and explain the solution, including its runtime and space complexity, before writing a single line of code. And then once everything is clear and the interviewer is okay with me implementing it, I would go ahead and implement a brute force approach or a different approach that I suggested before. Right, and the last step is then to step through the code with a mental debugger to make sure we don't have any syntax errors, and then test cases done. Cool, so let's go through this process. We're dealing with LeetCode 3701, compute alternating sum. And we are given an integer array nums. And the alternating sum of nums is the value obtained by adding elements at even indices and subtracting elements at odd indices. That means nums at position 0 minus nums at position 1 plus nums at position 2 minus nums at 3, etc. And we should return the integer denoting the alternating sum of nums. Cool. So now my first question would be to the interviewer, okay, what are the constraints? Are we always going to get an array? Can the array be empty? Or might we be given a nil reference or something like this? And for the sake of completeness, I would probably also ask, what is the value range of nums? Because there could be some hints in there that, could present an opportunity to come up with alternative solutions. Right, so there's no interviewer here, but there's LeetCode constraints, and it tells us that we are always given an array, and it contains at least one element, and furthermore, all elements are larger or equal than 1, so only positive numbers above 0. Cool, so now let's look at an example. Here we have the example 1357. In an interview, I would try to solve the problem using this example. So this is a very important step because oftentimes, when you run into a problem that you don't know immediately how to solve, you want to get an intuition what the solution could be. And the best way to do that is to actually go manually through trying to solve this example. And when you find a way to do it manually, you already found an algorithm to do it. Maybe not the optimal one, but you found one. That's the key point. You can always iterate on improving an approach later. And the more time you spend with the problem, the easier it will be for you to come up with different solutions or to optimize a first solution that you. So let's look at this example. We have the numbers 1, 3, 5, and 7. Well, okay, so I guess we would have 1 minus 3 plus 5 minus 7, right? Okay, so that seems straightforward. I don't think there's much to do. We could have like a simple loop that iterates over the numbers and then we just change the sign. We could also, just to give you an idea of an alternative approach, we could also group all the odd and all the even numbers if we wanted to. And so this would be 3, 7. Maybe we could first compute the odd, the even numbers sum and then the odd number sum and subtract one from the other. That's another possible way, but this problem is so easy that I think the solution looks quite straightforward. Now, example number 2 shows us the case where we only have one number. And for us, that means that if there's only one number, we still need to be able to sum it to our total alternating sum. So if we had an approach where we would iterate over the odd and the even examples, we need to make sure that just because the odd indices don't exist because this is index 0 where we just have one number, that we don't mess up the sum. Anyway, so that's just for illustrative purposes. So now that I understood the problem, I would suggest to the interviewer, well, yeah, I think we can just iterate over all of the numbers and then we just add them all up. But for every number at an odd index, we subtract it instead of adding it, and that builds us a total sum. And of course, that would mean we just iterate over the array in linear time, so we'd have an O of n solution. And we only need to keep track of the of the sum, and so we only need constant space for it. Right. And then the interviewer said, yeah, sounds good, blah blah blah. Go ahead, implement this. And I said, yes, I will do this. And just gonna use a result variable for the result, and we're going to return it at the end. Right. So now we need to loop over all of these numbers, and well, we need to know what index we're at. So I'm going to loop over the indices and the numbers in a Pythonic way using enumerate. Right, you want to do it Pythonic if you can. And I'm just going to update my result. Result plus equals n. Well, yeah, but I have to change the sign. So what I can do is I could say if I %2, if I modulo 2 equal to 0, that means we're at an even index. And then I just add n. Otherwise, what I'll do is I'll just subtract n. So yeah, that's pretty much exactly the logic that I explained earlier. And why make it more complicated or trying to be smart? This should work. So what I'll do now is I'll just take an example and step through the code with that example. So that's a crucial step. Now, if you skip that step, chances are with a more difficult problem, you will have a syntax error, you will have missed an edge case, and that's just minus points, right? So you want to have a clean solution that works. And the best way to ensure that is to go over your code with an example after writing the code. So let's start with nums equals 1, 3, 5, 7. So we enter the function, we set our result to 0. We have our array of nums. I'll just write that here for reference. Now what happens? I will be 0, right? I is going to be 0, index 0. N is going to be 1. Because I is 0, we're going to add 1 to our result. So our result now becomes 1. And we loop. Well, and we're done, and we loop again with the next I. So I now becomes 1 at index 1. N becomes 3. Now, since I is 1, we now enter the second case of our if statement, and we subtract 3 from 1. So we will get minus 2. Next iteration of the loop, I is now 2 at index 2. And that means we're going to add 5 to our result. So we're now getting minus 3 plus 5 is 3. And in the next iteration of the loop, we are at index I is 3, which is an odd number. So we're again in this case. And that means we're subtracting 7 from 3, which is minus 4, right? And as we can see in the example here, that's exactly what we expect. Now, you could just do one example case where you go through this, but because we have 2 here, let's just go over the other one as well. So when nums only has 1 number in it, well, what will happen is we'll just add it because that's its index 0, and then we're done. And at the end, we just return the result. So I'm confident that this code works. And at this point, I would ask the interviewer, do you have any questions or any other edge cases that I should consider? Because maybe the tests that I came up with are garbage and or not complete. So it's good to ask for feedback. And yeah, and then typically that problem is solved. And maybe then there comes a follow-up question, right? What if, let's say, what if you want to add only every third index? We want to subtract every third index, but we want to add when we add other indices, right? How could we do that? It could be like a theoretical question, right? So at every third index, then I would ask, well, including So what is the third index? Would that be at position 0, 1, or 2? In the maybe it says, oh yeah, that's a very good question, blah, blah, blah. It says at index 2, and then of course at index 5, 8, and so then I would say, okay, cool. So what I would do is, I would just change my little statement here. If I %3 is not 2, then I'm going to add it, otherwise I'm going to subtract it. And if we just take our little example code here, let's just test it real quick. So what we would have 1 plus 3 is 4, minus 5 is -1, plus 7 is 6. Let's just test this. You should see it here. Yeah, so the output is 6. Oh, obviously, LeetCode expects still -4 because it doesn't know that we changed the requirements. But yeah, so that is how I would approach that. And yeah, and it's an art in itself to write code in a way that you can easily extend it for other use cases. But as long as you keep your code simple and your approach clean, there is typically a way to do that. All right, so this concludes this little easy problem. And